Dear student, today concept is relative velocity. Let us consider two bodies which are moving in the xy plane. At given instant, r1 is the position vector of the first body, r2 is the position vector of the second body. This is the position vector of first body. This is the position vector of second body. This is particle 2, this is particle 1. The position vector is nothing but the vector drawn from the origin to the given point. R1 is the position of P1 with respect to origin. Usually it has to be noted as R10 vector, but we won't write like this. We will write as R1 only. Similarly, R2 is the position vector of P2 with respect to second, editor cut. Position vector of the second particle with respect to origin. It should be written as 20, R20, but we usually write as R2 vector. Usually it is represented as R2 vector. So student, now I am going to locate P2 with respect to P1. Not with respect to origin, already done, that is R2. Position of P2 with respect to P1. You have to draw from the reference point. Now P1 is the reference point. P1 to P2, if you draw a vector, usually people used to say R12 vector. That's correct. But here I am locating P2 with respect to P1, relative position. So this must be represented as R21, location of second particle with respect to first particle. This R21 is called a relative position. If there is a displacement of P1 and P2, this R21 represent relative displacement. Shall we say R21 as position of second with respect to first? As time passes, this if it changes, R21 is called as a relative displacement. Okay, if they are at rest, then R21 is called relative position. Position of P2 with respect to P1. From the diagram, you can see R1 vector plus R21 vector is equal to R2 vector. Using the triangular law of vector addition, then R21 vector can be represented as R2 minus R1. R21 is called a relative position of P2 with respect to P1. Rate of change of position or rate of change of displacement is called relative velocity. Now, let us differentiate both sides. Differentiation of R2 vector minus differentiation of R1 vector. d by dt of R21 is the velocity of second particle with respect to first particle. This is velocity of second particle minus velocity of first particle. V21 is called relative velocity. Of P2 with respect to P1. Similarly, velocity of first particle with respect to second. Relative velocity of first with respect to second can be written as v1 minus v2 vector. This is relative velocity of p1 with respect to p2. Student, I hope that you understood well about the relative position, relative velocity. Shall we learn a problem based upon this concept? Dear student, now let us learn the problem number 24. Based upon a relative velocity, we are going to learn. A man is walking on the horizontal road. With a velocity 4 meters per second. He is running. Raindrops are falling vertically downward with 3 meters per second. ரொம்ப ஃபாஸ்ட்டாக விழுது. What is the velocity of rain with respect to man? This is the problem. And what is its direction? That also we have to learn. Okay, student. This is the direction of velocity of man. This is the direction of velocity of rain, vertically downward. This origin statistic. What we have to calculate is velocity of a rain with respect to man is equal to what? Right, that is the problem. What is the velocity of a rain with respect to man? So, velocity of rain with respect to man is equal to velocity of rain minus velocity of man. So, you have to add minus Vm with Vr vector. This is Vm vector. I draw one more diagram, minus Vm. This is minus Vm. This is Vr vector. So, this is the origin. Okay. We have to add minus Vm with the Vr. Then what to do? Bring the tail of minus Vm to Vr vector. This is. Bring the tail of minus Vm to the head of Vr vector. Draw a vector from tail of first vector to head of second vector. This is a Vrm vector. Remember, this is minus Vm direction, this is the x-axis, this is the vertical direction, this is origin. Could you understand what is the direction of Vrm? Okay. It makes an angle theta with vertical statistic. Now let us calculate the magnitude of Vrm as well as its direction, angle with the y-axis. Vrm vector magnitude is equal to square root of Vm square plus Vr square, because the angle between Vm and Vr is 90 degree. This is the magnitude of resultant. The direction, if you calculate tan theta, that is magnitude of Vm by Vr. Theta is the angle made by this Vrm, rain with respect to man velocity with vertical. Then theta is equal to tan inverse of Vm by Vr. Suppose this man want to protect from the rain, he has to hold the umbrella at an angle theta equal to tan inverse of Vm by Vr. So, along x-axis this man is walking. Actually, rain is falling vertically downward. This real velocity of the rain. This is real velocity of the man. This man has to hold umbrella in the resultant velocity direction. This is VRM velocity direction. This is. The man has to hold umbrella like this in order to protect him from rain. For the man, the rain appears to fall in this direction. This is the relative velocity of the rain direction. So he has to hold in this direction in order to protect him, not vertical. If he stop moving, then he has to keep the umbrella vertically upward in order to protect him. I hope that you enjoyed a lot with this relative velocity. Student? Okay. Student, shall we go to river boat problem? Shall we learn the concept first and then go to the problem next? River boat. A boat is going to cross a river of width d. This is a river of width d. D is the width of the river. A river is flowing with a velocity Vr. Water is flowing with a velocity Vr from left to right. The direction in which water flows is called downstream. Against the flow of water, the direction is called upstream. Okay. Student, a boat capable of moving with a velocity Vb in still water. If water is still, this is the velocity of the boat. Suppose the boat is rest on the river with respect to water, but with respect to ground, it won't be at rest. It will be pulled with the direction of water. The boat velocity will be equal to velocity of the river. If at all the boat is not rowed, just kept on the water. But a boat capable to move with a velocity Vb or can be rowed with a velocity Vb in still water. Now the boat want to cross the river of width d. A is the starting point, let us take. B is the exactly opposite point on the other end of the other bank of the river. Boat initially can start in any direction along AB, along AC also, or along AD also. Whatever may be the angle, it can. But for one case, the boat can cross the river in the shortest path. In another case, can cross the river in the shortest time, no matter where it reaches the other bank. First case, no matter what is the time taken, but in the shortest path it has to move. Along AB it has to move, means it is the shortest path. The resultant direction must be along AB, that is shortest path. Resultant direction may be any direction, but the boat has to be crossed in short interval of time, shortest time. Then what must be the direction? It has to be initially rowed. What is the shortest time taken? These all are the things we are going to learn now. Okay, first of all, a general case let us take. The boat is rowed at an angle theta with the vertical in the upstream, not a downstream, in the upstream direction at an angle theta with the vertical it is rowed. This is the general case. After that, to move in shortest path, to move in shortest time, what are the conditions we can discuss? I think and I hope children you are following me. Two things you have to keep in mind. Later on we are going to discuss in what direction the boat has to be rowed in order to cross in the shortest path. What is shortest path? AB is the shortest path. Resultant direction must be along AB. That condition we are going to get. Next one, we need not to bother about in which direction it is moving. Or it may reach the B or D or somewhere else. Other bank it has to be reached in short interval of time. Two things we are going to discuss. Keep in mind. First of all, we discuss a general case and then we go for the special cases. This boat is rowed at an angle theta with the vertical, the shortest path AB, in the upstream direction. Okay. This velocity can be resolved into two components. One is VB cos theta, another one is VB sin theta. Shall I take a downstream along x-axis, normal to the river y-axis? I take like this. Okay, student, what is the resultant velocity of the boat along x direction? Okay. Velocity of boat with respect to ground in the x direction. So I take it as velocity of boat in the x direction, Bx is equal to Vb sin theta minus Vr. Suppose Vb sin theta is greater, means it will be along negative x-axis. Whatever it may be, later we discuss that. Okay, Vb sin theta minus Vr is the velocity along x direction. Similarly, velocity of boat with respect to ground in the direction of y-axis. Velocity of boat in y-axis direction. The component Vb cos theta. These are the components with respect to ground. Boat is capable to move with a velocity Vb in still water, but with respect to ground we are calculating. At the time we are taking river water into account. Just like I give one example. You are sitting in a bus. Bus is moving with a 50 km/h. You are saying bye-bye to your friend is standing on the bus stand, came for the send-off. Though you are at rest, for your friend, you are moving with a 50 km/h. Am I right? Suppose you are moving towards the driver, want to say something to the driver and walking with 2 kilometer per hour. Bus is moving with the 50 kilometer per hour. So what about your velocity is 50 plus 2, 52 kilometer per hour. While return to your seat from the driver, 48 kilometer per hour. Like that, this boat is on the moving water. Boat is on the moving water. Therefore, x component of the velocity of the boat become Vb sin theta minus Vr. This is the time to discuss about shortest time and shortest distance. Suppose the boat is crossing the river in the shortest path. Shortest path is AB. Resultant direction is along AB, then x component velocity becomes 0. Shortest path. What is the shortest path? That is AB. AB is the resultant direction. If so, resultant velocity is along AB, it means along y-axis, VBY is non-zero, but velocity of the boat along x-axis is equal to 0. Then only it is possible. Otherwise, the direction will not be along AB, somewhere else. VBY is not equal to 0, but VBX is equal to 0. Therefore, VB sin theta minus VR is equal to 0. VB sin theta is equal to VR. Therefore, sin theta is equal to VR by VB. Theta is equal to sin inverse of VR by VB. The boat has to be rowed at an angle theta with the vertical in the upstream at an angle sin inverse of velocity of river by velocity of boat. Then the boat will cross the river in the shortest path. Okay. Student, if the boat crosses in the shortest path, what is the time taken? No matter shortest path or any path. If the boat crosses the river, then y-axis displacement is equal to width of the river. Okay. If the boat crosses the river, then time taken T is equal to y-axis displacement along y-axis by velocity along y-axis, velocity of boat along y-axis. Displacement along y-axis, wherever it reach, it may reach the point C or B or D, wherever it may reach, but y component of displacement always is equal to AB. That is AB by VB cos theta, that is equal to D by VB cos theta. This is the time taken by the boat to cross the river if it is rowed at an angle theta. Okay. Suppose even if it is rowed at an angle theta, if it moves along AB direction, this is the time taken by the boat to cross the river. Shall we discuss the shortest time? To cross the river. We know T is equal to D divided by VB cos theta. For time to be minimum, cos theta will be value to be maximum. for minimum time. Cos theta must be equal to 1. Therefore, T minimum is equal to d by Vb. Then what is the angle through which the boat has to be rowed? Cos theta is equal to 1 means if cos theta is equal to 1, then theta is equal to 0. It means the angle made with the vertical must be 0. Therefore, the boat has to be rowed in the vertical direction, AB direction, but the boat won't be, resultant direction will be along AB. Its resultant direction will be along AC direction. Velocity of a boat in the river. This is velocity of boat. This is velocity of river. So velocity of boat in the river will be along AC direction. The direction is not important. In which direction it is moving. Boat is initial direction, it is rowed along AB, but it will be dragged along AC, but time taken will be short. Shortest time is T by Vb. This is the shortest time. Student, I hope that you have enjoyed a lot with the river boat problem and rain umbrella problem. A little bit you have learned about a relative velocity concept. Okay. Let us learn more number of problems in dynamics, relative motions, okay, or at the end of session we can learn, or during revision also we can learn more number of problems. Okay. Now let us pass on to circular motion. Circular motion is an example of two-dimensional motion. A particle moves in a circular path of constant radius. We are going to discuss. Student, this is x, y axis, circular path. This is of constant radius. A is the initial position of the particle. It is moving in the anti-clockwise direction with a constant angular velocity. Let us talk about angular velocity, angular displacement, angular acceleration. We have learned a linear displacement, rate of change of the change of position is called displacement. Here angular displacement we are going to discuss. This particle at t is equal to 0 at A, it is at A. After time t second, the particle reach the point P. OP is the position vector now, equal to radius r. Initial radius along OA x-axis. It is radius vector sweep out an angle theta. Now AP is called a linear displacement. And theta is called angular displacement. It is measured in radian, sometimes a degree also. Angle sweep out by the radius vector is called angular displacement. What is the relation between them, shall we? AP is the arc. Let us take this is x. Arc length. x is equal to r theta. This is the relation. Linear displacement x is equal to r theta. Relation between linear displacement and angular displacement. Okay, student, what is meant by angular velocity? Rate of change of angular displacement is called angular velocity. Okay, dx by dt is called rate of change of linear displacement, that is called velocity. Therefore, dx by dt is equal to, if r is constant, and d theta by dt, that is equal to b is equal to r into omega, where omega is called angular velocity. The rate of change of velocity is called linear acceleration, that's equal to r into d omega by dt. Then a is equal to r alpha, where alpha is called angular acceleration. Omega is called angular velocity. Alpha is called angular acceleration, where omega is measured in radian per second, and alpha is measured in radian per second square. Student, this A is called linear acceleration, also called as tangential acceleration. Along the tangent direction, this is the acceleration. Here v is called linear velocity, it is in the direction of the tangent, so it is tangential velocity, Vt. Look at this diagram. This is the axis. Initial position is at A. The velocity along the tangent, I take this is v1 vector. Final position is P. This is the radius vector. Tangential velocity at this direction is v2 vector. This radius vector sweep out through an angle theta. Therefore, velocity vector also changes by an angle theta. Are you able to understand? This is velocity. This is the radius, sorry. This is velocity. If the radius vector sweep out through an angle theta, velocity also sweep out through an angle theta. Student, angle between v1 vector and v2 vector is theta, because v1 turned through an angle theta. If at all this is v1 vector, v2 vector makes an angle theta. Understand? Student, we are going to calculate change of velocity. Change of velocity means final velocity minus initial velocity. Then you have to calculate minus v2. What is the angle of angle made by the minus v2 with v1? 180 minus theta. Then what is the resultant v2 minus v1? Here magnitude of v1 is equal to magnitude of v2. It means it moving with a constant speed. If, then what happens? Delta v is equal to 2v sine theta by 2. Change of velocity is equal to 2v sine theta by 2. For small angular displacement, sin theta by 2 is nearly equal to theta by 2. Therefore, delta v is equal to 2v theta by 2. That's equal to v. That is equal to v into theta. From the diagram, theta is equal to x by r. Rate of change of velocity delta v by delta t is equal to v by r into, this is a delta x a displacement or x is the displacement, by delta t. This is again velocity. So, displacement by time taken is called velocity v square by r. Then what is the direction of delta v? Shall we learn? Okay. Before that, del v by delta t is called another acceleration. This acceleration is called a radial acceleration because the direction of delta v will be along the radius. Let us see that also. This is called radial acceleration. That's equal to v square by r. Student, this is called a radial acceleration. The direction of delta v will be along the radius towards the center. So that's why it is called a radial acceleration. So a particle, if it moves with a constant speed in a circular path, then its tangential acceleration becomes 0, but it will have radial acceleration. So a particle can have two types of acceleration. One is tangential acceleration, another one is radial acceleration. So radial acceleration will be along the radius towards the center. Tangential acceleration along perpendicular to the radius. So at a given time, a particle may have two types of acceleration. Therefore, the resultant acceleration will be like this in between AR and AT. So the resultant acceleration, A is equal to square root of AR square plus A tangent square. Radial acceleration, just now we learned v square by r. V square by r, the whole square plus tangential acceleration r omega, or omega is equal to d theta by dt. Tangential acceleration r alpha, alpha is equal to d omega by dt square. So this is the resultant acceleration of the particle. If magnitude of tangential velocity is equal to constant, then alpha is equal to d r into, alpha is equal to 0 Therefore, it will have only radial acceleration. Okay. A is equal to AR is equal to V square by R only. So we have learned radial acceleration and tangential acceleration of a circular path. Student, we are going to learn the problem regarding circular motion in rotational kinematics. Not now. Okay. In rotational kinematics, we go in depth of problems. Till now, just you keep this concept in mind. Then only we can go to the dynamics part. There we will use centripetal force, centrifugal force. There this concept will be useful. Okay. After learning dynamics, sorry, Newton's laws of motion, we will go to the rotational kinematics and rotational dynamics. At the time we learn problems in this circular motion.